this is the Runcam OpenIPC ear unit. Now, this is one of the first off-the-shelf ear units for OpenIPC by a third-party manufacturer. There was the initial AIO or ear unit from the OpenIPC dev themselves, but Runcam have now stepped in to deliver an ear unit as well. Now, initially, this video was just going to be talking about the Runcam ear unit, but instead, this is now going to be a part one on my journey with OpenIPC. In this video, we're going to be looking at the Runcam ear unit, but I'm also going to be talking to you about what OpenIPC is. We're going to talk about some of the latency results that I've had from my tests so far. We're going to show you some flight footage with the Runcam ear unit, talk a little bit about the OpenIPC ear unit, and then at the end share with you some thoughts. Following on from this, there will be a part two, which is going to dive into the OpenIPC ear unit, the Mario that I've got here, and then there will be more flight footage. The plan is this is going to be a series of 3 to 5 videos. I don't know where this will end. Right now, I can definitely see it being 3. On my journey through this system, it may take a little bit of time, but hopefully this will give you an overview of the project, where it is today, and where it develops over the series of these videos. Now, before we get into this, I do just need to say that Runcam did send me this OpenIPC ear unit for free, although I have actually also ordered 2 of them myself, yet Runcam still haven't sent me them yet, and it's been well over a month. But they did send this one. I did not pay for it. I've not been sponsored. They've not seen this video before it's been published. And as always, my thoughts are entirely my own. Anyway, let's get on with it and let's take a look at what OpenIPC actually is first of all. Okay, so to start, we're going to take a look at this CCTV camera. Now, this is a typical 2-board CCTV camera design. On our front board, we have our image sensor under here, our lens, as well as our IR filter. There's then a MIPI interface that goes to the backboard. You can see on this side here, there's some power regulation. There's a flash chip, as well as all of the I/O and the main chipset on the back here. Now, it is this main chipset that actually makes OpenIPC possible, and it is an all-in-one ASIC that has been designed specifically for CCTV applications that allows you to basically build a single board CCTV camera. What's really interesting about these chipsets is it has an onboard MIPI interface for connecting to the camera itself. It has an ISP for controlling the camera, built-in H.264 and H.265 encoders. It has an Ethernet interface, USB interface, SDIO interface for connecting to an SD card, GPIO, SPI, UART, and all of the I/O that you would need to build a CCTV camera. What OpenIPC does is replace the original closed source software that comes on that ASIC with their open source software, and that allows you to do lots of different things, including building an FPV system. Now, when you replace the software on this ASIC, it is a little bit involved. It's not straightforward because it does come with a locked bootloader, but then you can couple this camera to a Wi-Fi interface such as this Realtek one here, and this then allows you to build a fully open source FPV system. Now, whilst this is a Wi-Fi interface, there are some things I do want to explain about this, because whilst it is a Wi-Fi adapter you're using, it isn't actually Wi-Fi in the sense of Wi-Fi specification. The OpenIPC software also takes full control over the Wi-Fi adapter and turns it into a video transmission adapter based on the Wi-Fi system, but it isn't strictly Wi-Fi, and as a result of that, it isn't going to work like a Wi-Fi camera. The behavior of this is going to be more like the FPV systems that we are used to today. The real big difference to understand about OpenIPC versus, say, DJI, HD0 and Avatar HD is those systems are all based on their own custom ASICs, whereas OpenIPC is based on an off-the-shelf ASIC, and what you're doing is replacing the manufacturer's original software, and then you're using that to allow you to build your own FPV system. one of the fundamental differences between how this will work and say the likes of DJI and Avatar is that their ASICs are based on LTE technology, whereas this is still based on Wi-Fi technology because it is a Wi-Fi adapter. But remember, as I've said already, it isn't Wi-Fi, and as a result of that, don't expect it just to behave like a normal, typical Wi-Fi camera. Now, with regards to receiving the signal from OpenIPC, there are as many options as there are for transmitters. It doesn't matter if you're using a DIY camera setup like I've got here, or you're using the OpenIPC ear unit. There are lots of options available. For instance, the simplest way is to grab yourself a smartphone on Android, and you can plug then a compatible Wi-Fi adapter into the side, and that will allow you to receive the OpenIPC signal straight on your phone. I'll actually demonstrate that a little bit more later on in the video. There are a number of Wi-Fi adapters that work, little ones like this one here, which you can build into a module if you want to, or you can get some more off-the-shelf ones that will work as well. If you want to take things a step further, you could get yourself one of these. This is a CCTV-based NVR board. These are actually based on the same sort of chipsets that the cameras use. So this board allows you to reflash it with OpenIPC. This then will give you HDMI output, allowing you to plug it into, say, an external monitor. The only downside to these boards is that they are limited to 60 frames a second. These boards don't support the 100, 120, etc. But what is a good thing about these boards is that they are incredibly cheap. I think these are available for like $16 or something like that. Again, all you would need to do is plug in a compatible Wi-Fi adapter on this to the USB port, plug in your display, power, and once it's flashed with the firmware, it's ready to go. Now, to be able to use this ear unit with something like a set of FPV goggles or even a larger display via HDMI, you're going to want one of these. Now, the 03W is a small computer. It's very similar to a Raspberry Pi or one of the other ones out there, although it's based on a different chipset. And the idea of this is that it allows you to install a special image that's been made for this that will give you low latency HDMI output via this board, and this then will act as a dedicated ground station for use with your IPC system. Now, as I showed earlier, I've built this into a ground station for a set of FPV goggles. I'm using this with my HD0 goggles. I've 3D printed a box here that holds that in. We've got a switch on the side for our DVR recording. I've got a power input there off a special cable, and we've got our HDMI at the bottom. I've chosen not to build the Wi-Fi adapter into this one a minute. You can do that. There is space in here to put something like this unit here into this for receiving. That isn't going to be an issue, and that's something I'm going to do in the future. Here and now, though, I'm using it with this AC1200 adapter stuck on the front with some VHB tape. The Redaxa offers a better performance compared to the likes of the NVR. The NVR is limited to 60 frames a second, whereas the Redaxa can do the full 90, 100, 120 frames a second, like is compatible on the goggles. All of these will offer a slightly different set of functionality and features, in the sense of this is going to give you the best overall options, the lowest latency, the most features. This will get you going for fairly cheap, or you can just get yourself a Wi-Fi adapter on your PC, and that'll get you up and running at the lowest possible cost. Now, one of the real great things about OpenIPC right now is the cost to entry, because one of its biggest sort of draws and features is the fact that you can get into this incredibly cheap. If you want to go down the DIY route, you can get into it for about $70, $80 if you shop around. You can get yourself a camera for $20, $30, a Wi-Fi adapter for under $10, the NVR for under $20, and you need yourself a couple of bucks and a couple of other bits, but you can definitely get a working system for under the $100 mark. If you don't want to go down that route, though, you can go down the off-the-shelf route. You can buy the Mario OpenIPC AAO. I think it's about $100 at the moment. The Runcam is coming in at $70, and you can get yourself a Redaxa Zero for around $40, $50, depending on the model you choose. So again, you can build yourself a more off-the-shelf system for maybe $150 to $200, or go DIY route for sub $100. It's entirely up to you. Now, when it comes to what we're going to look at next from Runcam, it is basically what you see here in a DIY platform customized and developed more towards FPV, but the fundamental basics of the hardware is the same. It will be a camera based on a compatible chipset with OpenIPC firmware with a compatible network adapter. And in fact, Runcam are actually using this specific adapter on their build. Now, before we jump in and look at the Runcam, it's worth noting that they are not the first to make an all-in-one air unit for the OpenIPC system. OpenIPC themselves have released their Mario AIO. Now, when they say AIO, it's not a flight controller, it's an air unit, a VTX, as we would call it with Avatar HD and DJI. This is the one that is officially endorsed by the dev team. It is similar to the Runcam in many ways, but it is quite different in others. With regards to functionality, there are differences, but the basics are, it has the same chipsets, the RF setup. You see we have our antennas there. I will do a deep dive and a review on this on the channel in the near future. If it's published already, I will put a link to that in the description, but it is just worth understanding that the Mario is officially designed and endorsed by the OpenIPC dev team. The Runcam, I believe there's been communication between Runcam and the OpenIPC dev team. I wouldn't call it officially endorsed right now. They are not saying it's not endorsed, and they have added a section on the OpenIPC Telegram group for this board, but I have seen some chatter around the fact that today we are seeing a number of manufacturers start to release hardware for OpenIPC. The dev team seem to be allowing, sort of running with that, but it isn't clear what the long-term approach will be with regards to how these manufacturers are going to support the OpenIPC project. If you're someone who's been around the likes of ExpressRS and Betaflight, today all of those projects require manufacturers to work with them for officially supported hardware. That's to ensure that users get the best experience. It's early days for OpenIPC with regards to this, and as I've said already, right now they're going to run with this as I understand it, but it needs to be understood in the longer term how the likes of Runcam and the other manufacturers are making hardware can then contribute to the project itself, because it's not just about banging out cheap hardware. There has to be some benefit for the project. That benefit may be financial, that benefit may be in code, in development. It's not clear at this time, but it is something that does remain unclear, and it does still need to be sorted out. Okay, so this is it. What Runcam are calling their WifiLink VTX air unit AIO, whichever term we want to go with. This is an air unit designed to be specifically used with OpenIPC. Now, we'll just go through what we get in the box first of all, and then we'll take a closer look at the hardware itself, and then we will move on to the software as it comes from Runcam. And then we'll talk a bit about IPC a little bit more later on. So, in the box, we have the air unit itself, the VTX and camera. Very similar to anything else that you've seen out there, dual board design, although there are some good and bad things looking at it already. But we do have a fan on the top. We have our camera connection, some ports. Again, we'll look around that more in a minute. Moving into the rest of the box, if I tip it over, there is a card here with some instructions for the user manual as well as support, which is really good to see. We then, in the bottom of the box, have our connection cable for connecting it up to a flight controller. They do show it being connected up to the likes of a SpeedyBee. We have a network cable for connecting it up to our network so we can do the configuration, although you don't actually have to do the configuration this way. And then we do have two small included antennas. Alongside this, there is this small pack of posts and screws, again for the assembly of the VTX, and we'll look at that a little bit more when we look at the hardware in a bit more detail. Now, the kit they've sent me is the kit that also includes the additional Wi-Fi adapter. This is for use on your ground station. Now, we will talk about ground stations again a little bit more later on. There's going to be a lot to follow up on this video, but this is an AC1200 Wi-Fi adapter. This is one of the ones that is known to be compatible. They include two antennas with it as standard. And then there looks to be a USB adapter cable. So we've got a USB-A for the adapter that goes into there, and then USB-C for connecting into our smartphone or our PC or our other ground station devices, depending on what setup you want to choose. Now, the kit as Runcam ship it here is designed to use your PC or a smartphone as the ground station. But don't worry, FPV goggle users, you can use something such as a Razda 03W that will actually create a ground station with a HDMI output that you can use with traditional FPV goggles. That offers really low latency. I've actually ordered one of them. I don't have it in to look at today, but we will be taking a look at that maybe in this video if it arrives in time. If not, we will do it in a follow-up video. Okay, so taking a look at the camera and the module in a bit more detail. Now, starting with the camera, it is based on the Sony IMX415 sensor. It has a 160-degree field of view, and it has resolutions of either 1080p 60, 1080p 90, or 720p 120 frames a second. Now, the camera and module has an input power range of 9 to 30 volts or 3 to 6S, and it has a custom connector for that located down here. It weighs 30 grams and it has a built-in power amplifier capable of up to 29 dB of output. Now, when you look at the module, you'll see that it is a dual board design. We have our RF module on the top and we have our video processing module on the bottom that our camera connects to via this MIPI connection. Now, this board is based on the SigmaStar SSC338Q chipset. That is the main chipset you see there. Now, looking around the rest of the board, we have an SD card slot over here for our onboard DVR and configuration. We have our connections and pads. Everything is padded out here with our main input connector here. And you also have an RJ45 connector over there. With regards to the RF board, that is the top board you see there. This is based on the Realtek RTL8812 chipset. Has dual UFL antenna outputs. And then we have a heatsink and fan located on the top here to try and keep it cool. It's quite interesting that there's no heatsink and fan on the Star chipset. We'll have to have a look at that under the thermal camera to see how that performs. As you look around it, it clearly isn't the most resilient of VTX design. I think this probably needs some work. You're going to want to try and protect this somehow. It's also quite interesting that there's no heatsink on the bottom of that chipset there. We'll have to have a look at that under the thermal camera to see how it performs. But overall, it is very much like you've seen from other manufacturers. If we just take a look at the sizing, width-wise, we're talking 31.8, so 32 mil that way. The boards this way are 32, but with the wiring, you're probably talking 35. And then height-wise for the stack from the connector to the top screw, you're talking 26 millimeters. Again, it'll mostly go into a space you'd get something like a Vista or an O3. It's definitely bigger. Now, just comparing it to an O3 air unit, you can see there it is bigger. There's no question about that. But it is interesting just how small they have been able to get it. And whilst it's certainly not a direct replacement for an O3 air unit or Vista today, it's definitely a much smaller package than some of the others that we've seen before. Now, I've just separated the boards to give you a closer look at them in more detail. What you will notice, first of all, is that they're different colours. And actually, something I've noticed is this top Wi-Fi board doesn't appear to actually be designed from Runcam. I was looking on AliExpress and I'd already ordered these, and it turns out the Wi-Fi board is this board here. It is literally this board that I ordered for my custom OpenIPC build of AliExpress, and that is what they have used in this board setup. So what it looks like is Runcam have designed the camera and the main processing board and have chosen an off-the-shelf Wi-Fi board for this build. That is partly because of it's probably easier for them to do it this way. This is still somewhat of a test product, but that also explains why it's a little bit of a clunky setup. Now, just flipping over to the inside of the board here, you can now see our SD card slot. This is actually a little bit of a fudge to get to. The card goes in from this side here and not actually this side on the other outer corner. So as a result of that, you're going to need to separate the boards to get to it. Also in here, you'll find your SPI flash, what looks to be a voltage regulator, as well as some additional pads down there. For the setup on the bench, my advice would be to separate these boards and do it this way rather than have them together. And then once you've got the configuration all done, then put them together and start your build. Now from the factory, this board does come pre-installed with OpenIPC already on board. It is pretty much the standard version, although they have added a couple of extra scripts. They allow for configuration via this SD card slot. Usually with OpenIPC, you'd actually have to connect it to, say, the likes of Wi-Fi or connect it to a UART adapter for configuration and SSH in, whereas Runcam have added a script for the main basic configuration. But if you want to do something a little bit more in depth, you're going to want to use this network cable that they've included, although it is worth me noting that this cable won't work into a hub. This is designed to go directly into your PC, so you're going to need to plug this into your LAN port on your laptop or your computer, manually configure your IP address as per the instructions, but you're not going to be able to plug this into, say, a hub and connect to it on your normal network. Now, with regards to the initial configuration, what you're going to need to do is put an SD card in the air unit and power it up. When it powers up, it will then save a file on the SD card for the configuration. Then power the air unit down, put that SD card in your computer, and then you can start the basic configuration, which I'm going to walk you through next. Now, when you open up the SD card, you will find two files, one called GSKey and one called user. Now, the way OpenIPC works is it's similar to ExpressLRS in the sense of it needs a binding phrase or a key to communicate. There is a drone key, which is on the air side and camera, and a GS key that goes on the ground station. They actually copy the GS key onto the SD card for you. So to allow this to communicate with your chosen ground station, you're going to need to place that GS key on that ground station, or alternatively, you could replace the key that is on the camera already with the key from your ground station. This is somewhat of a binding process. I will say it can be a little bit annoying to get right at times, but what has happened recently is a generic key has been used, and in many cases, the generic key that comes on the camera will work no problem at all with the ground station. But if it doesn't, you are going to need to make sure that you do have the correct keys on both sides. The next file you will see there is called user. Now, this is the configuration file for this air unit. This is something that Runcam have introduced and isn't typical of OpenIPC, but I actually really like the way this works. This allows us to set the channel that we want to use. OpenIPC uses the standardized Wi-Fi channels. It is based on a 20 megahertz carrier, and you can see here all of the channel options available with the frequencies, and you would simply set the channel number there. I'm going to choose channel 161. We then have the power options available down here. You can see as standard it comes with number 58. You then have the encoding option for the camera, H.264 or H.265. Depending on your ground station, you may want to set it to H.264. I'm going to leave it at H.265. We then have our video resolution options. So again, we have the option of 720p 60, 90, 120, 1080p 60, 90, and I've chosen to set it at 720p 120 here. I'm actually going to change it to 720p 90 for my flight because that is the closest match to the output I'm going to use for the HD0 goggles. Then you've got a couple of other options in here available. Flip the camera image. You've got options to rotate, contrast, hue, saturation, luminance. I'm going to leave all of them as standard. And then when you've made the changes here, you would simply click save. Now, to demonstrate this, I'm going to show you it on my smartphone a minute. Now, I've already got that Wi-Fi adapter connected via USB-C. The software that I'm using here is called Wi-Fi View. It is an app that is available on the GitHub for this system. I've already configured this with the ground station key. If I go into the settings in the app, the channel is set as well as the codec as well. You're going to need to make sure the channel is on the right channel, as well as the codec being correct. As I did mention earlier, you do need to make sure that you have the correct keys installed as well. The keys have to match for it to be able to connect. Something else I will just mention on this app is if you do make any changes whilst the app is open, I have found that you do need to close it and open it again before it will actually work with the system. Now, to power this up, I have the air unit connected to a SpeedyBee flight controller over here on a short saver. Before we do that, though, I just want to mention, make sure you have a fan blowing air over this before you do kick it in. Whilst the Wi-Fi adapter has a fan, the main video chipset doesn't, and it also doesn't have a heatsink either. I think this should actually have a heatsink on board because it gets very, very hot. So when you're doing your bench testing, do have a fan blowing some air over it. You should do this with any of the digital VTXs anyway, but both this chipset as well as this camera do get very hot in normal use. Now, what we're going to do is power this up. When you do that, it will take sort of 20 seconds or so to kick in. What you will find is the system will boot, it'll go through the process, and then what you should see in a second is our video signal appear on the screen. Good 10 to 20 seconds before that kicks in, but when it does, boom, there you go. You can see it's kicked in. I have to say, the image quality on this looks really, really good. In fact, I'd go as far as to say the image quality on the bench looks easily as good as Avatar HD, the original DJI FPV system. And in fact, even O3 doesn't really look much better than this on the bench. This is currently set to 720p 90 frames a second for use with my HD0 goggles. You can see that over there. You can see there. Everything looks really, really good. Now, if you power this all up and you're not getting video, make sure that you do have this key thing done properly. As I have mentioned already, it's really important that your ground station and your air side have the same key. I haven't showed you how to do that in this video, but you do need to make sure that you have transferred the keys over. I would advise trying it first though, because there are default keys that everyone is using now, and it may just work out of the box. Now, with regards to the latency on this system, I will be talking about that a lot more later on, but if I just show you there, it does look very good. I have done a bunch of latency testing on this with the HD0 goggles, and I will be doing it on this display as well, and I'll be publishing that data later on in the video as well. I have shared a sneak peek of that on the channel already, and it certainly isn't looking too shabby. Now, obviously, one of the big questions many people will have about OpenIPC is around latency. Now, I've been doing a lot of testing around this, and I'll be honest, this is a subject for an entire video in itself. But in this video, I just wanted to give you an overview of the results that I've had in my testing so far. Now, there are some things that you do need to understand, as I've said already, about OpenIPC. It is not a fixed latency system in the sense of it works like HD0, but it's not a completely variable latency system like DJI and Avatar HD that has a two-way link and prioritizes image over latency. However, it isn't a peg fixed system because there is going to be increases in latency as a result of dropped packets and dropped frames. But what I want you to do is have a look at what is the best case scenario, what am I getting here on the bench, and then comparing it not only to other versions of its system, but also what it looks like compared to, say, DJI. On the chart here, you will see how the new Runcam Air unit compares not only to a standard OpenIPC system, but also DJI O3, the Vista, and using OpenIPC on another ground station. Now, my initial testing is all done using a Redaxa Zero ground station on the HD0 goggles. You will see there are two separate sets of numbers. We have the average first pixel, that is the first change on the screen, and then the average full frame. Now, you will see that the Runcam WifiLink is showing an average first pixel of 36 milliseconds and an average full frame of 43 milliseconds. This is a little bit higher than a standard OpenIPC camera. This is a completely DIY setup that anyone can make. That is coming in at 33 milliseconds on average and 42 milliseconds to a full frame. What I will also note is that I have seen much lower latency numbers on the OpenIPC DIY setup compared to the Runcam Air unit. I've seen latency as low as 25 milliseconds, but that is in limited runs. The averages, though, come out at 33. Comparing how OpenIPC looks to the likes of, say, DJI O3, you will see there it isn't quite as low latency as O3, but it is very comparable to using the Caddx Vista or the Runcam Link Air unit on a set of Goggles 2 and Integra, and it is very similar latency to that indeed. With regards to how OpenIPC performs on different ground stations, as I said already, my initial tests were done on the FPV goggles, but what you will see on the end is that there is a massive difference in the performance of OpenIPC when using it on, say, a smartphone. I've recently got myself a Samsung S24 Ultra and I took those tests tonight, and as you can see, it is a massive increase in latency compared to what you would get on a dedicated ground station. Now, there is a lot of complexity here around the latency that I haven't discussed in this video. For instance, the Samsung has a variable refresh rate display, and there can be differences in how that performs depending on what setting you have it in. I haven't put Avatar HD on that chart. What I'll tell you is, at the moment, OpenIPC is a little bit higher than Avatar HD, comparable to O3, not as low as HD0. This, though, is still very early days. It is not a time to be taking all of these numbers as absolute fact because there is so much changing in the system all of the time. You can configure it to behave differently as well. It will be dependent on the refresh rate. It will be dependent on what settings you have in the system, depending on the MCS modes as well. But what I can say is that there's no massive thing to be concerned about here with regards to latency. It is low enough for most people. It will be variable depending on what you're going to do, depending on the setting, and there will be some movement of that latency in use, and I'll talk about that a bit more later on. But what it isn't is anything silly like 100 milliseconds, 200 milliseconds, 60, 70 milliseconds, even like that. It's definitely in the end that most people accept is absolutely fine for general FPV freestyle use. Now, this isn't to say things couldn't be improved in the future with regards to using it for racing. There is so many options that you will be able to change, so there is a very real possibility those numbers could come down even further. But from a quad perspective, there certainly isn't anything to worry about. With regards to planes and wings, no issues whatsoever. You people will be more than happy with the numbers that I'm seeing here. Next, it's time to take a look at some footage and show you what this actually looks like in the real world. Now, this is broken up into two sections. You've got my initial test flights, which is literally my first ever flight on this, and me just getting to grips with it. I didn't actually record the audio of that. I've done the audio here at the studio, but the second section, which was done on another day, is all recorded at the field. You get my raw thoughts as I'm flying it and pushing the system a little bit harder. We'll also take a look at a little bit of penetration testing behind some trees, but there isn't a lot in this. I do comment on that, and I'll talk about that a bit more at the end of the footage. This isn't all in all out and out testing. We're still at the very start of my journey here with the way OpenIPC behaves. Okay, now what you're about to see is my very first few flights on OpenIPC. Now, I didn't actually record audio in these flights. This was my testing as I was trying to get to grips with how the system felt. Now, you will notice here on my first flight, as I took off, there was some breakup of the image. Something I've noticed in all of my flights is arming and takeoff does seem to break down the link for a second or two. Now, in my first few flights, I was getting a lot of sort of juddering in the image. It's not as noticeable in the DVR here, if I'm honest. On the goggles, it's a lot more noticeable. The settings here are at 90 frames a second into the HD0 goggles and 90 frames a second or 100 frames a second, I should say, on the camera. Everything felt quite jerky, not smooth. I was also getting a lot of random breakup as well. And what is interesting is I was seeing more in the goggles than I am on the DVR footage, which is quite interesting, which would imply it may be related to processing as a result of me recording and viewing the live view at the same time. And it almost is as if it prioritizes the recording image over the live view. I need to do more testing whilst not recording. Here, really more than anything, I am being very tentative, just moving around the field. I'm not doing anything here other than getting to grips with how it looks, how it feels. This footage is actually a little bit slower than reality. Something I have noticed as well on the DVR recording is, depending on the frame rate of your timeline in your footage, it might not be at the correct speed. I haven't edited this at all because I have no audio baseline to go with. Later on in my footage, I actually talk whilst flying, and I was able to use the audio track as a timing track because it was recorded separately. Whereas in this video here, it isn't. This is probably 25% slower than I was actually flying. But I'm going to leave it at this because it gives you a nice view of how the footage looks and some of the quirks of it. Now, you will see that there is a little bit of jerking here and there. I am experiencing some dropped frames or latency, and I do talk about this a lot more later on, and I'll definitely discuss it at the end. In the recordings, I am talking about this as latency. It's not strictly the case that it's high latency all of the time, but I am definitely feeling that a disconnected feel at times, and it's interesting compared to the latency that I'm seeing on the bench. It is generally based around signals, so again, it could be dropped frames. You are seeing issues in the footage as well. But on a positive note, the first thing you will see is that it does look very nice. The image quality is decent. If I was to put an opinion on what the image quality is like, it's a lot more like Avatar HD than DJI 3. It's actually a bit of a mishmash between DJI original FPV system and Avatar HD. There is compression, and you do see waves of it in the image as well. But all of this is adjustable. There is a lot that can be configured on this. This is stock. This isn't optimized for freestyle. It's not optimized for anything. It's the standard settings as it has come from Runcam, because that is what I wanted to show you here today. With regards to the image breakup, and I will show you a little bit about the penetration performance later on, it isn't up there with 03. It's more like Avatar HD in my testing so far, although it is worth understanding, as I have said in this video already, this isn't a two-way link. There is no packet retries here, so it is not going to have the same levels of penetration as DJI 3 or even Avatar HD. Certainly the way the image breaks up is a lot more like Avatar HD, and you will see that when I actually go around the trees a little bit more later on. It is similar, though, to what I've seen on Avatar. Really, more than anything, this was a shakedown flight. Then I come back another day and do some more testing and push things a lot harder than I am here. For me, this was simply about getting to grips with how it looks, how it feels for the very first time. Okay, so this is day 2 of testing. We're going to now have a look at how this performs in the settings I've got here. I've made a change. Yesterday I was testing it on 90 frames a second on both sides. Now I've got 120 frames a second on the camera and 90 on the goggles. I've also made some changes and moved some stuff around with regards to the layout of the air unit in the quad, because I'm not convinced I had it 100%. So I'm just going to do a couple of checks, all looking good. So I'm going to assume I'm in acro mode here, and I don't have a timer. So we're going to play this by ear and see how it goes. And see how it feels. Oh, very stuttery. I have noticed the stuttering on takeoff from the quad, but there you can see it still is particularly jerky. I'm not sure how it's going to come out on the DVR, I will say that. I'm just going to keep it fairly low and simple on the field. It's going to yaw. Let's just yaw a bit. Okay, it's not too bad. There's definitely image stutters in the image. Ooh, we lost the video feed then. Only over there. And really, I just want to give you an idea of how this looks in the real world. There is a capacitor on this build. This is actually also running on a back as well, so there should be no issues there with regards to power or the voltage from the battery. But yeah, just to give you an idea there of how it looks. What I don't have at this moment in time in this setup here is any confidence. If I'm honest, I can't say it any other way, because the image is juttering, stuttering all over the place. It's just... all I'm doing is just flying around the field. When the detail is there, it actually looks pretty good. But... oh, a dog walker has appeared over the other side of the field. My nemesis. So I'm just going to keep it over here. Yeah, it's extremely stuttery. It's extremely stuttery. Now, this could be as a result of the frame rate mismatch. Oh, total loss then. I'm not going to do anything really other than just show you how this looks. Ooh, seagull overhead. Get this side of the field. Yeah, I'm not even wanting to push it into that area there, because I just don't feel comfortable at all with it at this moment in time. The truth of the matter is, I need to do a lot more testing. Obviously, this is the Runcam air unit. I want to now try it with the OpenIPC air unit. Okay, so we're on pack 2. Now let's just put a bit more sort of pace in it, just to see how it feels. It is windy here today. Interesting, at times it doesn't look too bad. And if anything, actually, the more I push it, the better it sort of looks. I don't have a lot of camera angle on here, as you can see. But yeah, that is... look, it's... interestingly, that's definitely... it's... see, it's weird. That first flight, I just wasn't comfortable with how it felt at all. Whereas... almost in the slower movements, it looks worse, which is quite interesting. I'm not sure I'm comfortable doing a flip on it. I don't really want to bin the aircraft, because this is the only Runcam air unit I've got at the moment. They haven't sent yet the others that I've been waiting for. All right, let's do one high, shall we? Here we go. I'm not going to do it low, that's for sure. Okay, confidence is building, as you can see. Look, it's working. Shall we have a look at what the breakup looks like again? This is a bit risky. Let's just... Let's just go through the trees, and now you're really starting to see that sort of compression breakup. Ooh. Oh yeah, that really does look like early DJI. Oh, I went very high then. But okay. Ooh, I had a spike of latency then, which I crapped myself on, is the term I'll use. Okay, so I've now added a bit more camber angle for this flight, which will just allow me to push things a little faster. There's definitely latency. The latency I was feeling then. Also wind. Yeah, I'm definitely feeling the latency at times. Ooh. Compared to what I would usually expect. I can't quantify it. I can even hear it. I'm hearing sort of my stick movement without the corresponding video action happening. Yeah, it gets very hard there between the trees. I wasn't easily able to see the branches then. It's also starting to rain here today. So if we go in there, let's go. Ew. It's absolutely flyable. That's for sure. I'm not sure. I think you just need flight time to be able to sort of start building confidence. And even I'm starting to do that now. Although you then start to think, I'm not going to go in there. I'm not comfortable with what I'm seeing. My spotter is over the other side of the field. I can hear my dog. I have a radio. We use radios. So my spotter is with me. It's my dog barking that you can hear in the background. A bit more confidence going down into the gap. I didn't want to go too far. But yeah. Okay. Ooh, that was a bit weird. Now, obviously, these settings are not optimized for freestyle or anything like that. These are just the standard settings. So let's just go a little bit high. And then again, I'll just go some higher up footage before we bring this one in and end this here and then go back to the studio. It's definitely progress. It's definitely flyable. It's definitely usable. I guess now it comes down to what are you looking for from an FPV system? Now, I'm back on the bench after those couple of flights, and I've just been doing a bit of digging on this sort of latency and detached feeling that I was talking about in the video. I'm not 100% clear what the cause is yet, although all things are sort of pointing towards the Redaxa Zero and the HD Zero goggles. Now, I've done a lot of testing on this with regards to frame rates. So I've tried it on 90 frames a second, 100 frames a second on the camera and 90 on the HD Zero goggles, because remember, these only support up to 90. And I've tried it as 120 on the camera and 90 on the HD Zero goggles, and it really didn't change. I'm definitely getting stutters. I'm definitely getting sort of a jerkiness and a lack of... I'm going to call it latency, but it's a hesitation at times. Others are reporting something similar though, and what is interesting, when I looked back at the footage on the Redaxer that records on board, it actually looked a lot better than what I was seeing in the live view. And it's almost like the Redaxer is prioritizing the image feed for the record over the live view, and I'm sort of getting a few slowdowns. I am running not an early firmware, but there is new firmware in the works for this, which I'm going to try in the near future. I don't think it's anything on the Runcam side. I'm using the stock settings other than the refresh rate. I haven't tried anything else. There is a lot of things I could test here. What I'm trying to do initially is do this as it comes, and then I'll spend a bit more time with my personal testing when it comes to messing around with the settings to get the best possible results. What I would say here and now, though, is out the box, it does work well. With regards to the Redaxer, just to show you this, because I don't know if I lifted the lid on this earlier, this is in quite a big case, but it doesn't need to be this big. If I just show you in there, so the Redaxer is in the bottom there. I've got a heat sink on there, and there is a fan in the back of that as well, blowing air onto it. It will not be overheating, that is for sure. You could really shrink this down if you wanted to. You could build the Wi-Fi adapter in, which I will do later, and you could make this box a lot smaller. You could easily get this down to the same size as the likes of the HD0 or the Avatar HD VRX. This is just a box that someone has created that does the job, but it's not been optimized for size at all, but there's plenty of room for optimization here. Right now, I'm going to continue to test. Next, I'm going to be doing the Mario AAO, and I want to fly that without touching this side of things, and then get a feeling for, is it still performing the same? Am I still getting that juttery feeling? What is interesting now is sort of the more I pushed it, the more comfortable I got with it. As with all things, you just need to get used to it. I think there's a bit of work that needs to be done, but this isn't necessarily what everyone else is finding as well. It does look very smooth on the smartphone. I just can't easily fly it on a smartphone. I have seen people actually take their smartphone and put that in a set of goggles, or a goggle unit to be able to do it. And perhaps I might try doing that as well. But here and now, more work to be done. But just don't take my comments as, oh, the system is bad. There's just a need for more understanding, more work on getting the optimal setup. Okay, so before we wrap this one up, it's time for me to share with you some thoughts on the Runcam Air unit, as well as my initial findings on OpenIPC. As I said at the start, though, this is a part 1 video. Part 2 is going to be concentrating on the OpenIPC AIO that you see here, and then more flight testing, comparing it to the Runcam, but also doing some more testing around penetration and things like that. I can't fit everything into one video. It's going to be hours long if I did. Now, to start, we're going to talk about the Runcam Air unit from a hardware perspective. It's not great. It works. There are some real quirks here. The design is terrible. Runcam have done a bit of a quirky thing here where they seem to have designed the camera board themselves and used an off-the-shelf board for the RF side of things. The way it mounts on one side is just terrible. It's poor. It's going to break if you're not careful. It'll be fine in a plane or a wing, but in a quad, you have to be really, really careful. I think as a development or testing platform, it's absolutely fine. But it isn't a finished product, and Runcam, in my opinion, need to now go out and design their own RF board, or design this in a way that you don't have that cantilever, that C shape that can snap in the event of a crash. It is not robust enough for everyday use in, say, a freestyle quad. Other than that, though, the Air unit does work okay. The fan is quite cheap and quite noisy, but that's really all I can say about it. What is great, though, about the Runcam Air unit is the price. It is the cheapest way, I think, right now to get an off-the-shelf OpenIPC Air unit and camera. It's cheaper than the OpenIPC one themselves. It doesn't quite have the same specs because they're different camera sensors, but it's definitely a great way to step into OpenIPC. But as a finished product, there is a lot more work, I think, that needs to be done from Runcam. It's not terrible, but as you've seen, there are some bits about it that just need to be changed. Now, as for my initial findings on OpenIPC, I have to be a little bit careful here because I've only had a limited amount of flight time. I've had quite a bit, but it's still not enough like I've had on DJI and Avatar and things like this. It's also worth me re-stressing that this system is in constant development. OpenIPC is not a product that you can just go out and use today, in my opinion. It is an open source project that is developing, continuously evolving. It is what I would call in the alpha state of development. There really isn't a sort of starting point, ground zero today, a point where everyone should start here and they will all get the same results. Due to the way we've got different pieces of hardware appearing and the way the system is just so configurable, your results will heavily depend on the settings you use. And it's not just about the frame rate, the camera settings, it's about the MCS rates that you choose, bandwidth, things like that. The system is somewhat infinitely configurable today, and that's great, but it also comes with a downside, because the downside is there is no good middle ground starting point. The place that Runcam have started everyone seems okay. So it's 20 megahertz bandwidth, MCS 1, all of that seems okay. But what the system doesn't have is all of the sort of more advanced link features that we have on Avatar HD and DJI. It's a highly compressed link, but is one way. There is work being done on a two-way element that allows it for auto-adapting of the MCS rates like DJI and Avatar HD do. I think I probably need to cover the MCS element in an entire video in itself. The easiest way to think about it is different sets of settings depending on the link quality, because obviously if the link quality is really good, you can pump through more data, but as the link quality drops down, you want to reduce the bandwidth or the data you're pumping in, so you need to compress the image differently and change how much data you're putting in. It's a lot more complex than that, but the difference is DJI and Avatar constantly adapt the MCS rate depending on the signal, whereas this today doesn't. This just has the rate that's set, and it will be fine until it isn't fine. But there's work being done on that. There's projects that are going to allow adaptable MCS rates via your RC control link, as I understand it. There's projects going on about changing the codecs. There's just so much going on this project. It's really hard to say, oh, it's great or it's bad. You're basing what you've seen on how it performs on the settings that you've got. What I will say is this. I have been extremely critical about this project in the past and the system. However, I have also taken a step back and started again with the dev team. There is no doubt it's incredibly interesting. It does work. The project is doing some really interesting things. Today, it is not a replacement for DJI 3. It's not a replacement for Avatar HD or HD0, but it is flyable. It is usable. I am feeling in my testing some variability in the latency. I need to understand this more. That isn't to say everyone is doing that. I need to understand the settings that I'm using versus what other people are using. There are times where I feel just very disconnected and then it comes back fine. It may be dropped frames. It may be that it's lost a packet of data and then it's skipping until the next one. There are so many elements of this that need to be understood, but I am feeling quite a variability depending on the signal behavior. But as you have seen on the bench, it is absolutely capable of very low latency. Things like the variable MCS rates may massively help with that, because what it will be able to do is change the bandwidth, change the link settings to maintain the latency rather than it fluctuate. I've got no data though around that latency fluctuating. All I can tell you is I have a feel that there are times the image judders or the image changes and I just feel a bit disconnected from the quad, and that has to be latency. There's nothing else that can be. But as you saw in the flight footage, I pushed it harder and harder in my field, just basics, and I got to grips with how it was. I have also seen some incredibly impressive footage from some of the guys doing testing, pushing it really hard in freestyle. In fact, almost into racing scenarios where they have been able to tweak the settings to get it really, really good. And I'm seeing some great results from those guys. So there's potential here. And I guess the final point to make is it's There is massive potential in this system, and now we're at the point of waiting to see if it lives up to it, because as all things with open source projects are, they are complex, they are challenging, they are difficult. There will be people there today who won't be there in a year. It's really early days for OpenIPC, and I think right now, if you're interested in messing around with something, it's absolutely worth a look, but it is not going to replace your existing dedicated FPV system. Now, for me, it's time to continue testing. I am impressed, but I need to do more work, and that's what's going to happen in part 2. So if you're interested in seeing that, please do make sure you are subscribed to the channel. Finally, I just want to say a big thank you to the OpenIPC devs who have helped me a lot to get me to the stage of where we've been at here today, to be able to show you, be able to test it. I'm looking forward to sharing with you more testing in the future. I'm not going to put a timescale on that video. I'm going to start that today. It's September, mid-September at this point of me recording this. This video will probably go out 4 or 5 days after this bit. And I'm now going to get this bench work done, and then get it into a frame. And then it's time to test the OpenIPC air unit. And then we'll get that video out. Finally, I just want to say, if you have found this video interesting and you'd like to support the channel, please do check out links to my Patreon as well as buy me a coffee. It is only through the support of my patrons I'm able to keep making content on this channel. And if you'd like to support us to allow us to keep making content in the future, please do consider checking it out. I want to say a huge thank you to all of my patrons. I keep saying this, but we would not be able to do this without your support. Anyways, there will be links below if you're interested in getting them. Stay safe. I will speak to you soon.